Hey everyone! Today, we're diving into a fascinating story about our planet's history and how a massive volcanic eruption turned ancient oceans deadly. Around 113 million years ago, something catastrophic happened that affected the tiniest creatures in the ocean. Tiny, shelled plankton near the ocean surface began to die out, and their shells became smaller and thinner. But here's the intriguing part: while these plankton were struggling, their seafloor cousins remained largely unaffected. So, what's the deal with this ocean extinction event? Let's break it down. First, let's talk about plankton. These tiny, single-celled organisms drift through the upper ocean and build shells from calcium carbonate. They're like the tiny architects of the ocean, and they matter a lot. Marine life builds about 5.8 billion tons of calcium carbonate a year, and plankton might account for up to half of it. These tiny shells play a huge role in the carbon cycle, which is crucial for regulating Earth's climate. Now, fast forward to 113 million years ago. During the Albian Age, large plankton species with thickly built shells were common. But in the following Albian Age, those species disappeared, and smaller, thinner-walled plankton took their place. This shift in plankton types is significant because it indicates a change in ocean chemistry. And that's where the volcanic eruption comes in. The volcanic eruption likely came from the Kerguelen Plateau, a volcanic province in the southern Indian Ocean. The gas erupted into the air and eventually reached the ocean, causing it to become acidic. This acidification affected the plankton, but not all of them. The seafloor plankton, which build their shells from sediment grains instead of calcium carbonate, were less impacted. This is because building plankton shells pulls alkalinity out of seawater, which neutralizes acid. When surface plankton reduced their shell building, more alkalinity remained in the water, providing additional buffering capacity for the deep ocean. The study, published in the journal Science, found that the shift in calcium isotope ratios of planktic foraminifera across the Aptian/Albian boundary was among the largest documented over the past 600 million years. This indicates a significant change in ocean chemistry. And it's not just a historical curiosity, ocean chemistry is changing again today. The surface ocean has already crossed a threshold that researchers had set as a limit, and acidity has risen by about 30% in the past 200 years. So, what does this mean for our oceans today? Well, it's a cause for concern, but it also highlights the importance of understanding past events to prepare for the future. In conclusion, this ancient ocean extinction event is a reminder of the delicate balance of our planet's ecosystems. It's a fascinating story that connects the past and present, and it highlights the importance of studying our planet's history to better understand and protect our environment. So, the next time you see a tiny plankton, remember that it might have a bigger impact on our world than you think. Thanks for watching, and don't forget to like and subscribe for more fascinating content.